50, something like this. And if I don't get done, I'll go ahead and do another video of it like I did those other ones. I think I did videos of the ones we didn't get through the other day. Put them out there. It's not like I go home and don't care anymore. Sometimes you just don't turn it off. Now let's see if I put a point right here. I should be able to get that to look halfway decent. Learned that from my sketching, teaching you how to sketch in CAD 1. Isn't that kind of counterintuitive? Teach you how to sketch in CAD 1. Shouldn't be sketching. Got a 12 kip force here, or kilonewtons, excuse me, kilonewtons. Oh, let's get that a little bit closer. Don't you think? We can make that a little closer. It should be right over top of that V shape, and I guess that should have been a little closer to the center. 12 kilonewtons. Why did this not go away? There, that gives us more room. Then we've got AY. I think it must be pinned here, isn't it? Yeah. AY, AX. Oh, we got another bar going down through here. And then we've got, this is point B, and this is BX. BY equals 0, doesn't it? See, this is one of those situations where the roller is on the vertical axis. Then we've got a 6 kilonewton force here. We've got 10 meters. Right here. 10 meters here. And then we've got 8 meters between these two. The most important part of the problem, right? The hand gets stuck in there. The most important part of the problem, and I screw up the drawing. Here, we'll fix that. I think that's it, isn't it? Now there are other members shown in that picture, right? But this is all we have to, really we wouldn't even have to deal with this one right here. That really doesn't even come into play, does it? Not yet. Probably will next chapter. But we got the 12, the 18, the 6, AX, AY, BX. Okay, we're good to go. So we just solve for the reactions. Solve for the reactions at A. Well, we got sum the forces in the X. Actually, we're solving for, excuse me, the reactions at A and B, right? That's what the test will say. Find the reactions at A and B, and then I'll list them. So we got minus 6 right there, kilonewtons, minus BX plus AX. Do you see why BX is going to the left? Don't you think that would be the case? Because you got these forces, you got this 18 kilonewtons out here really pulling down on this thing. Well, if this whole structure were one solid, it would be trying to push that whole solid back into B, wouldn't it? So BX has to push back out. The wall has to push back out.
Wouldn't we need like an angle then?
Do what?
Wouldn't we need an angle for, if it's 18 kilonewtons, wouldn't we need an angle since it would be pushing to the right or something?
No, this, I mean, the 18 kilonewtons, the given force is just straight down. Okay, but I'm just saying for BX, we just know that BX is pushing to the left because all of this is pushing to the left, right? But this 18 kilonewtons is much farther away, and this is going right through the B. But this is much farther away, so it's got a bigger lever arm, doesn't it? And it's a bigger force and it's a bigger lever arm, so it's probably making this thing go this way, rotation-wise, which is pushing against BX, pushing against the wall. Intuitively, you would know that if you were holding these parts in your hand and pulling down on that, the bottom part of it's pushing back into the wall, isn't it? The top part of it's trying to rip out of the wall. That's why AX is going back to the right to counteract that. Okay? And these two forces are pushing down, so AY has to push back up to counteract that. So I think it's important that you see the common sense part of it. To me, it's common sense. We might prove that BX isn't really doing that. It's not going to be the case in this case. But we may think common sense tells us that it's doing one thing, and it's totally the opposite of what you think. And that, again, is where we just say, you know what? I guessed the wrong direction. It's no big deal.
I did.
You did? And it came out a negative value, right?
Yeah.
And that you just say, well, okay, I guess it goes the other way. But then if you stop and think about it, okay, it does go the other way. And you just proved it mathematically. Summation of forces into Y, because I always do it that way. Got negative 18, right? Trying to push this thing down. Minus 12, we just talked about. Plus AY. Now see, this time we get to solve for AY instead of AX. And that's about 30, isn't it? These go to the other side of the equation, become positive. 30 kilonewtons. We said AY was going up. It came out a positive value, so it is going up. Well, we still can't use that up here. So we do sum the moments. Now I did it relative to A, which is smart in this case because that's where it's pinned, right? So we get rid of AX and AY. So we've got, if we look at that, we've got BX. Now that's trying to make that thing go go clockwise, right? So it's negative, and it's 8 meters. Did I put feet anywhere? No. 8 meters away from A. Then we've got the 12, which is making it go counterclockwise, which is positive kilonewtons, and it's 10 meters. Then we've got 18 trying to make it go counterclockwise, and that's 20 meters, right? Done, right? Minus 6 kilonewtons at 8 meters. We weren't done. Remember, when I say right, I'm always wrong. We gotta have that in there too, right? Relative to A, what all makes it spin? 12, 18, 6, and BX. BX and 6 are along the same line, okay, but we don't know what BX is yet. So they're both 8 meters from A. This one was 10, this one was 20. Excuse me. So we can do the math in that now. BX goes to the other side of the equation, becomes positive. All of these stay the same, so 12 times 10 plus 18 times 20 minus 6 times 8. All of that divided by 8. And you should end up with 54 kilonewtons. It did come out a positive value. We said it was going to the left, so it is. Take that value, go back up here. BX we know is 54. AX stays where it's at. These both go to the other side of the equation, become positive. And last time I checked, that was 60 kilonewtons to the right. Because we said it was going to the right, it came out positive. So it is. Questions?
How How did you get up to 54 kilonewtons per BX?
Okay, so we did, I didn't write it down, but we did, to get that, we did, if I can find my mouse, we did, Bx goes to the other side of the equation, right? So it would be 8 Bx equals 12 times 10
Okay.
plus 18 times 20 minus 6 times 8, and then Bx would be,
By 8.
right, it would be, which all of that comes out to be, all of this becomes 432 divided by 8. Okay? Anything else? But see, the math part of it you're supposed to already know. But the writing the free body diagrams and all that, that's where the tricky part comes in. But, and I'm helping you with the math part. I don't have a problem with that, but honestly, you should already know that. I think you have to have math before you have this class, right? It's a prereq. Isn't a math a prereq? I think. Used to be. Maybe it's not anymore. I don't know. I would have to question why not. Because you got to be able to do the math. But that's all right.